So another quickie here, I need to make this little collar that goes between the handle and the hammerhead. I'm going to make this out of this little guy here. This is 1.5 inch outer diameter and 1 inch inner diameter. The handle will fit through here, but I do need to turn this down on the lathe. It needs to be 1 3/8 on the outside, and then I'll do the angles and so forth to make it look correct. Alright, here we go. All done. Nicely polished little collar. That'll get welded on. Probably one of the last things I do, actually, when I'm attaching the handle. Came out quite nice, though. Alright, so full disclosure, once again, it is actually about a week later, and I thought this came out perfectly. It sort of did, except I was in a rush right at the end. I cut it off a little short. Real simple. I just measured it. In the meantime, I did make another one. This time the correct height. Let's see how that looks. Yep, I would say that's just about perfect. Oh well, just another few hours of my life wasted. On to the next part. Alright, we are on to the handle now. This is what I'm going to use right here. This is 1 inch or 25 millimeter 4130 steel. Now 4130 is a member of the chromoly family of steel. That just means that this steel has been alloyed with chromium and molybdenum. It has a fairly low carbon content, however, so it's very easily weldable, which is important since the only thing that's going to hold this thing on is going to be weld, so I really can't risk having a brittle weld, but the alloying components do add quite a bit of strength. I believe it's around 85% stronger than normal mild steel. It's pretty much the best of both worlds. I was going to go with plain mild steel for the handle, but I was kind of worried about if the head weighs around 150 pounds and it gets dropped, you know, on the handle like this, especially at an angle, it could potentially bend the handle, maybe. So what we're going to do here is we're going to cut this down to size. It's going to be around 17 inches long. That will basically go all the way through the hammerhead, and it'll be welded on the other side below this plate. We're going to stick it in the lathe, and I'm just kind of cleaning it up. It's pretty much the right size, but if you ever bought steel from a mill, you'll realize that none of the steel is actually straight or round or consistent for that matter. The other problem is this is 1 inch outer diameter, and all the rings and that collar will have a 1 inch inner diameter, which means they are not going to fit together. So I need to kind of take maybe 5/1000ths of an inch, probably it's about 0.125 millimeters. It's not a lot, but it'll clean it up. It'll ensure that we have a nice, perfectly round, perfectly straight surface, and it'll just allow the rings to fit over it. Alright, we got it all done. It took a little more than I wanted. It ended up being something like 20/1000ths of an inch taken off totally before it was nice and straight and nice and round and consistent. The result is, this is the collar I made earlier. It's a little bit loose, It doesn't need to fit tightly. It is going to be welded onto this handle, but basically hoping to have a really tight fit so there would be no adjustments needed. It rocks a little bit, but I'm sure you can just see how much it moves. It's really not that much. This is not exactly a precision machining experiment, so I'll have to deal with it. I'll probably just base it with a little bit of tape or paper or something like that, and just to keep it centered when I do weld it on. But that's good enough for now, I think. So of course my battery died and I didn't realize it, but what I've done here is using the lathe, I'm able to just put little marks at very precise intervals, and this marks where the rings on the handle are going to go, so I don't have to kind of fuss with it at all. I know exactly where they're going to be. Alright, we are on to the individual steel rings of the handle. Now the first step is I've got some round tubing here. This is 1.25" outer diameter, 1 inch inner diameter. This needs to be 1 3/16, so I just need to take a fairly small amount off, about a 32nd from each side, or the radius I suppose. So in the past when I've made these rings, they can be really tricky because they're really thin. These are about 0.15 inches. When you cut them out, if there's any discrepancy at all, you can notice it because, you know, the tiniest amount off is actually a fairly large percentage. It's kind of all relative, right? So if this piece was a little bit thinner on this side than this side, you would notice. Now this is the first hammer I've made since I got my lathe, so now I can precisely mark this out. These are basically going to be cutting guides. This isn't going to be the shape of the rings, but it's going to be where I start the cut, the angled cut in towards the center at each one of these markers. And then when I have to cut from the other side, I'll have an exactly identical line that corresponds to the other side. I'll explain more once I actually start doing the cutting, but this should give me a pretty nice guide for cutting these rings out. Now I'm going to make 20 rings. There's only 10 on the handle, but I figure given the past trouble, even with this newer precise measuring method, I expect to screw many of them up. And I'm just going to pick the best 10 out of the bunch, basically. Now I need to mark the center line on exactly opposite sides of this round tubing. The reason being, I need to, when I'm cutting out the rings from an angle, I need to stop right in the center. And then when I flip the piece, I'm going to be cutting from this side, and I also need to stop in the center. So what I'm going to do here is I'm going to use this machinist vise, and these are parallels. These are precision ground, basically standoffs. You would put these in a vise this way. You'd have one on each side of your workpiece, and they could, you know, stand your piece off the floor of the vise. You really need to use the parallels to bring the work up, and you don't risk hitting the vise with any sort of milling cutter or anything like that. Just a brief explanation, but these are pairs and they are perfectly matched to each other. So, and just to give you an idea of how precise they are, there's a little bit of oil, and they're actually held together. I'm not touching the bottom one. It's just such a precision fit. There we go. Alright, I've got it in the vise here, you can see. So both sides are accessible. I can get to the bottom as well. I'll just have to flip the vise around. But now I can just measure this distance from here to here and half it and mark right down the center, and then use the same measurement on the back side, and I'll be good to go. Alright, we're ready to rock here. I put a little clamp at the end. I'm barely touching it. I could see no daylight on either side, but I was getting slightly different measurements from here to here, so with the clamp on there, I'm getting within 1/1000th or 2 of an inch. So I'm dead on. Now, I measured this at 1.694 inches, so half of that is 0.847. What I've done is set my calipers to 847, and this blue stuff is a die. All I'm really going to do is I'm going to use the jaws of the calipers to just kind of ride up the side and scratch right down the center. I'll do it on both sides, and I'll even do it on the end here. You'll see why, but let's get to it. Alright, we're all done. I think you can see that nice scratch. I did kind of scratch it from this side like this, and then I did it from the other side just to be sure. Alright, so we're getting ready to cut out the metal rings on the bandsaw. Now there's one more consideration I have to make. If you've never used a bandsaw before, it's just a giant blade that travels around these large wheels, and the wheels turn in a clockwise direction. So the blade comes straight down, and when it touches a round surface that you're trying to cut, it tries to, as it's going straight down, it tries to roll the round object over. And I really can't have that happen because I'm trying to cut a precise angle. So what I've done over here is I've got these precision V-blocks. First things first, if you remember, I marked out the end of this so I could get the lines, the scribed lines, straight up and down. Alright, I don't know how well you can see this, but if I get the straight edge in there, it looks pretty straight to me. Both the upper and the lower hash marks touch the square at the same point, so I'm pretty confident that my scribe lines are exactly on the top and the bottom. So what I'm going to do to prevent this from rolling over is I'm going to do this. I cut an inch off the end of this. That's right here. And then get this out of here. I turn this on the lathe. This is just a piece of scrap aluminum. I made exactly the outside diameter of this metal, and this is exactly the inside diameter of this. So very carefully slides right on. I'm going to butt these up like this, and I'm just going to tack weld in 4 places. Now, as far as how I determined what angle this cut should be, I went with a pretty simple solution. I literally scanned in the handle, and then I just manually measured that angle. As you can see, it's 56.5 degrees. That should get me pretty damn close. Alright, so forgive my lack of possible coherency. It's past 1 o'clock again. But this is where we are. I think I'm ready to cut this out finally. I've been doing a lot of finagling in the background. I didn't film a lot of it because it's just awful boring work, but I've got my material to make the rings from. I've got the end of it welded on here that's reversed 90 degrees, and then my little aluminum extension so that it can't tilt this. It'll keep it flat against the table. Now I did make a little bit of a miscalculation. When I'm cutting this very first few rings, this is actually, let me get it right, that very first ring right here, this is basically off the table, and it's kind of hard. It can tilt and like that. So what I'm going to do is I've got one of these 4-inch drill press vices, and I've sanded the top and that surface. So what I'm going to do is I'll mount it upside down, just like so. I'll clamp it. This edge will go against the miter gauge here, and then it'll keep it nice and flat on the table, nice and square with this surface, and then I'll just be able to push it right through the blade. Once I've done a few of them, I'll be able to get rid of this. Now, as far as how I'm going to line up the blade here, I've actually got this thing. This is a 1-inch dowel with just a little piece of scrap steel on the end of it, and it will slide just like that. So now, make sure you can see that. Now I have a flat surface back here. I'm going to use that dial indicator trick that I showed you on the lathe, where I'll stick the dial indicator down here somewhere, and this surface will press against the dial indicator, and I'll be able to accurately measure how much I moved the workpiece this way. I need to move it about 0.15 inches. I've got the reference marks on here, but the bandsaw blades are wavy, and trying to line them up is not the most precise thing in the world, so I'll use a dial indicator just to make sure I'm at least in the ballpark. If I'm off by, 5 thousandths of an inch or something like that, it won't be the end of the world, but I kind of needed a sanity check because every cut I make on this side of the material has to be lined up perfectly with the cuts on the other side of the material. And once they start getting off a little bit, they're all going to be off. So it's something to really pay attention to. Having redundant measuring methods is going to be crucial to this part, I think. Just to show you the bandsaw blade here, you can see how wavy it actually is. It does this so that it cuts very slightly on the left and the right side of the cut, so that the blade can't get trapped in its own kerf, basically, its own path, and then it just gets jammed in there. It's not good. So it actually cuts slightly wider than the thickness of the blade itself. A quick thing I wanted to mention, if you've ever used a bandsaw like this before, the two giant wheels, one on top, one on the bottom, do not actually run true to each other from this direction. The top one's usually slanted a little bit, and the bottom one's usually fairly straight. Now, the problem with this is it makes the blade not perfectly vertical. It's not really a problem in just about any case, but in this case, I need this blade to cut through right to the center on the top, and on the bottom it'll also need to be in the center. If the blade was leaning front to back, it could cut too far or not far enough, and it's just going to be a nightmare basically. So I actually had to misconfigure the saw, and yeah, the blade is probably it's at least ½ an inch off. The gullet of the teeth here, the little spaces in between the teeth, are actually supposed to be centered on this wheel, and you can see they're almost right to this edge, but it's kind of a necessary evil in this case. I really need this blade to be perfectly straight up and down, and I've adjusted all the guides the same way, and I've also adjusted it so it's not leaning left or right. I've been at this for probably 7 or 8 hours or so, just setting up this cut more or less. Alright, so I wanted to show you the final stage of preparation. I've got the vise clamped onto the workpiece, and what I've done is I've taken an old cell phone and I zoomed it all the way in so I can see the blade. The blade is right there, and where it's going to line up. I'm going to try to line up the right side of the blade from our orientation right with the edge of my mark, which I've basically done here. And it doesn't really matter where I start as long as I do it consistently. And I will use the dial indicator as a redundancy or a check or whatever you want to call it. So this is it. Wish me luck. Alright, so good news and bad news. Good news is The cuts are centering properly. You can see I got them all basically on that center line. If I flip it over, more or less the same thing. There's a couple that are a little bit off, but I could fix that with a Dremel or something like that. The bad news is you'll see a large discrepancy in size. You'll notice this very last one is actually bigger. This is actually the correct size. I started measuring them, which I should have done from the beginning. They're all small. The reason being very simple. When I move each cut 0.150 inches, 150 thousandths, I wasn't taking into account the kerf of the blade. The kerf is the material that's removed from the cut. So I'm basically cutting all of these too short because I'm not factoring in the materials being removed. Long story short, I actually have to move the dial on that 200 thousandths to make a 150 thousandths wide ring. So I guess I'll just continue on, and I'll probably just scrap all these, and I'll keep making cuts, see if I can make them consistently. I think I'll continue to use the dial indicator to try to measure this side, but then the problem is they're all very slightly different. I'm sure you can even tell on camera. The blade just not rigid enough. It's, you know, one of the advantages of a bandsaw is the very thin blade and the flexibility of it, but it's working against me in this situation. It's resulting in a fair amount of variance over here. Even though I'm measuring it just about right, you know, the blade, when it starts cutting on the very edge, it maybe deflects a little bit, and then it just starts a slightly off cut. But they're close enough. I think if I cut them all a little bit big, and then I'll just hand sand them to size afterwards, that's probably the best bet. Now, as far as cutting this other side, I've swapped my little aluminum brace to the other side here. As far as cutting the other side, I'm literally just lining it up by eye. So if I wanted to cut to that one right there, you know, I literally am just doing this and kind of adjusting it until I think it's right. And I think it's getting close enough. I really don't have a better method of doing this other side at this point, I don't think. Especially with the variance in thicknesses, it's just kind of crazy. Even measuring it is tough because the slots are so little, I can't really super accurately measure that size. I can just barely get the tips of the calipers in there, and I get a lot of variance even along the length of it, so the blade must be wandering slightly. So long story short, I'm just going to have to rely on eyesight and a whole lot of squinting and trying to figure it out. Alright, so through a ton of trial and error, I figured out a fairly simple method of doing what I need to do here. Now, I've got the blade in the last cut I made, and it's pretty simple. All I really do is I make sure we're lined up with that cut. I haven't removed it yet. I back it out. Of course, I kind of need two hands for this. Keep a good grip. Over here, I back it straight out of the cut. But not so far that I'm not making contact with the indicator over here. I back it up till I can get this on 0-ish. Right? We're making contact with the indicator. I've still got this held over here. We're in line with the cut. Now I'm going to clamp the miter gauge right here with this clamp. I can't do it because I have too many hands in operation here, so hang on. Alright. We got it clamped now, so now the miter gauge can't move forward or backwards. Now all I do is I come over here, and I'm at -5,000 now. It just kind of moved a little when I clamped it. So now I'm going to move the workpiece to the left. If I can slide it with one hand here. It's 100,000, 200,000. 200 and come on. That's 250 thousandths. Remember, it started at -5, so we're at 250 thousandths. I just undo that clamp and then I just push it through the blade again, and you can see we're about the correct distance away. And that's it. And here's the result. We've got 10 pretty equally sized pieces. They passed the eyeball test. I see some very slight variance, but they all meet the center line on both sides pretty close. So now all I gotta do is just flip it over and use the old eyeballs and hope I get this lined up close enough anyway. And this might seem absurd, but the way I found, or the best way I found to line these up is I line up the best I can by sight, and then I just move it a little bit more, and then I end up being just about perfect. For whatever reason, I seem to be able to judge close, but not quite enough. I'm always a little short, so I just do it the best I can, and then I move it, and then it ends up being nearly perfect. So whatever works, right? Alright, boys and girls, I think we're done here. I've used about as much material as possible. This is just getting short enough that it's hard to keep this flat against the miter gauge there. So I'm calling it. Alright, so after some careful measuring here, I believe I've got 11 that have quite a bit of potential. You can see there is some discrepancy, but in some cases just some little burrs and notches that are preventing these from fitting together. There's one big gap right there, as you can see. It's not on the other side. I think that's the one that was kind of the iffiest, but I'll sand and grind these down and I'll eliminate the worst one. I've kind of got a little bit of a safety margin because on the hammer there's 10, but the last one is fairly well hidden. So if I have one that's kind of shady, I'll stick it down there. And what I'll probably do is, if I have real discrepancies in sizes, I'll just kind of like put the biggest to the smallest so the transition isn't as noticeable. But looking at this, they all are pretty damn close, and hopefully I can sand most of it out. So we're getting there. Alright, full disclosure, once again I've remade a part. This is the old handle and this is the new handle. If you remember, I started with 1-inch stock here and I had to take about 25 thousandths, about a half a millimeter off this to get it round. And the problem with that is it's kind of a decent amount of slop in this. And it's not a big deal, but trying to position each one of these rings, there's nothing really to clamp on, and I have to make sure they're not cocked that way, or you know, up and down, basically 3 dimensions, of course. So it's going to be kind of tough to position these all accurately, and that might not seem like a big deal, but I suspect I'll save time, because if I can have these rings nice and tight, the leather strips that go in between the rings, I can make them all the same size and they should all fit. Obviously I have to do the leather last because these have to be welded on, and the welding heat would, you know, catch the leather on fire, so that would be a slight problem. I need to weld all these rings on, build all the leather strips, and then install them afterwards. So I really want these to be as tight as possible so there's less leeway, there's less room for error, basically. Now if you come over here, I started this with 1.25" stock, so I was able to remove the material and still have plenty left over. So this is pretty tight. Actually quite difficult to do with one hand, apparently. You can see quite a bit tighter. In fact, I keep catching. There's still a little bit of wiggle. Just a tiny amount, but you really can't get away with much less than that, or these would be really hard to move around. And the collar I had to hand fit because it was actually had a slightly smaller inner diameter than the little rings. So I actually hand sanded this one. This should be very tight. So as before, I have marked these out in 850 thousandths increments as precisely as possible. However, I do want another piece just to do some sanity checking for me when I am welding these on. So what I've got over here is, this is a 1-inch thick flat bar. This is the milling machine here. I have not used it yet other than to drill some holes. This is my first time, absolute first time going to mill something. So I figured it would be a good experiment, and also I'll get that little feeler gauge. I can just kind of stick it in there and make sure I have the right distance before I weld everything in place. What I'm doing here is I'm just taking 75 thousandths off. That's about 2 millimeters. Then I'm going to flip it and I'll do the other side and I'll try to get it right at 850 thousandths. Alright, here goes nothing. Wish me luck. Contact. Alright, so I've got both sides milled here. Let's see what we got. I wouldn't expect, I wouldn't get your hopes up here. I don't think I'm exactly a savant machinist on my first try. It's really annoying to do with one hand. Yep, I overshot at 843 it looks like. Let's try the other side. That side's a lot closer. 849, so only a thousandths off on this side. I just realized that if you look at this machine, I didn't really take the time to square up the table and make sure it's perfectly level and parallel to the head. I should have done that ahead of time, so that's why I got a few thousandths difference at one end versus the other end, but I've got one end at 849. I'd say that's pretty damn close. Just a little sanity check here. I know my lines should be 850 apart, so this should be really damn close. Yeah, I would say we nailed it. Alright, here's another idiot mistake for you. I was just mocking this up to make sure I had it at least close, and I realized those little lines I made on the lathe, they are all in the wrong place. I put them 850 thousandths apart, but I didn't include the width of these rings, so you know, this one has to start right here on this line, and then the width of the ring, and that's pretty much the difference, is the width of the ring from this line to that line, and then it just keeps getting longer and longer and longer. But good news is I do have the piece I machined to 849 to use as a spacer, so I'll still get my accurate spacing and it will look right. In fact, let's see what we got here. You get the idea. What I'm going to do now is I'm going to mark with a Sharpie where each one of these are, so I can put them back in the same spot, but also I need to mark where I'm going to grind the base material of the handle a little bit so that when I weld, I'll have a gap to weld into, and then I won't burn up the ring, very thin ring. And I'll have to grind back the weld, and I don't want to remove all of the actual weld material. So I'm going to use a die grinder, die grind the surface on two sides. I think right on this flat side, maybe 1/2 inch, 3/4 of an inch wide. I'll just die grind it out, and I'll have a nice gap to TIG weld into on both sides, and that should hold them in quite nicely.
Years later.
Alright, so it's time for the leather on the handle. Now, I've spent probably 6 hours or so trying to come up with a way to do this. The problem is, if you remember, these metal rings didn't come out perfect, and they were all slightly different sizes and slightly different cuts, so I don't really have any consistency there. Furthermore, each of these rings is actually rotated slightly from the one next to it. Just due to the cuts being slightly off, I kind of averaged out the differences between the different sizes and shapes. So it would look good to the eye, but they're not. That means that they're not all perfectly in line with each other. It's not much. We're talking less than 1/16 of an inch. Probably about 1 millimeter of variance, more or less. But as a result, this gap in between is slightly inconsistent, and that means that I can't cut the leather the same way I cut the rings. I intended on doing that, but it's going to be so hard to cut that leather precisely and not tear it with a bandsaw. So basically, after several hours of experimentation, I've got paper templates I've tried, I've got failed attempts at manually cutting the leather. I finally decided on this. I literally made a mold of the inside, the gap in there. I just kind of put this on there, I let it set up, I cut it in half, and then I flattened it out on my scanner, and I scanned it in, and then I photoshopped the resulting picture, because this shows the full width, but each of these other pieces actually have to overlap, so it needed to be wider than this. So I photoshopped it. I think I have that one. It's actually right here. You can see what it looks like. I had to Photoshop a little bit on both sides to extend it for the overlap, and then I've just been hand fitting this piece. I finally transferred it to some steel. I've been making a piece of leather, test fitting it, adjusting the steel, you know, whatever tolerances need to be changed. Back and forth, hours and hours later. I think I'm really close. I'll actually show you the most recent one I did. Let me put the camera on the tripod here. Alright, let's see if I can do this. Now, I did cut these a little bit large, so that I can kind of just scrunch it up and just kind of squeeze it into these little gaps. It's going to be kind of hard to do by hand here, but I don't know if you can see. Yeah, that came out pretty well. I'll have to kind of tuck some of these edges. I don't know if you can see that on the camera, but the kind of the underside of the leather is sticking out a little bit. Maybe I'll just glue it down, but it looks pretty good. Again, just these little parts here, I'll kind of have to manually, you know, manipulate each one to get it just right. Now you see I cut them all long so that they overlap, maybe 1/2 inch, 12 millimeters or so. What I need to do now is skive these ends, which basically means I'm going to sand them at an angle so that when they overlap, they don't create this big, bulky lump. There'll still be a seam, but it won't be quite as obnoxious. I'm going to use my old school sander for this. It's pretty underpowered for most things, but it's perfect for leather. I'm going to make a bunch of these bad boys, maybe 15, 20. Might try to vary the sizes a little bit, and then I'll start hand fitting them on there. And the handle should be pretty much done.